Welcome back to the Deep Dive. Today we're unpacking a fascinating piece of hardware you sent us. It's one of those quiet heroes of modern infrastructure, the Thor Broadcast H-IP-32RF. Now this isn't just a random box of electronics. It's really a financial bridge between all that old copper wiring in buildings and modern internet streaming.
It absolutely is.
So to put it simply, this device, it takes video streams, digital packets coming over an IP network, and it converts them into traditional, old-school analog broadcast channels. It basically solves what we call the copper problem.
Precisely. And that's the key. If you're running a huge facility, think of a 100-year-old college campus or a massive hospital complex.
Or even a big hotel.
Exactly. A big hotel. You've got millions, literally millions invested in existing coaxial cable. You want the flexibility of IP video, but tearing out every wall to lay fiber is just way too expensive.
Right.
So this box acts as an integrated headend system. It's an IPTV decoder, a demodulator, and a powerful analog modulator all in one. It saves a fortune in recabling costs.
Okay, so let's get into the specs. Let's unpack the input side. I'm seeing 2 gigabit Ethernet ports here, which suggests it can handle a tremendous amount of data. What does that actually look like in real terms?
It's all about density. Each of those GE ports can manage a maximum throughput of 840 megabits per second.
For each port?
For each port. And that capacity isn't for just one stream. It can process up to 64 distinct IP programs, whether they're bundled together as an MPTS or coming in as individual SPTS streams. The machine just handles it.
Wow, so it's managing huge bundles of channels coming in from the internet all at once.
That's right.
With all that data coming in, how complex is the format translation? I mean, does video have to be in one specific format, or can it handle anything you throw at it?
It has to handle everything. I mean, in today's world, you're all about efficiency, so it supports the latest compression standard, HEVC or H.265.
Which is crucial for saving bandwidth.
It's critical. It lets you deliver high-quality video using, half the bandwidth of older systems. But just as important, it also supports H.264 and even the much older MPEG-2 format. It accepts this whole diverse digital world before it starts that conversion process.
Okay, so now for the output. This is the part that's sort of a miracle to me. We go from digital gigabits to 32 separate tunable analog channels. That is a massive density in one box.
The 32-channel density is the real engineering feat here. It spans a frequency range from 47 all the way up to 862 megahertz.
And that pretty much covers the whole spectrum you'd need.
It covers the distribution needs for almost any commercial facility. They can pipe in network feeds, internal training videos, local signage channels, whatever they need. And since these signals are going to older displays, signal integrity is paramount.
Right, because you don't want a snowy picture at the end of all this.
Exactly. The source material specifies a video signal-to-noise ratio of at least 60 dB. That number is the key metric. It's what ensures your beautiful 1080i digital stream doesn't break up or get all that static snow on an analog TV.
And it's globally compatible too, right? NTSC, PAL.
Yep. It supports the key analog standards across North America and Europe and Asia, so it's ready to go anywhere.
Okay, finally, what makes this practical for the facility managers who are actually using it? It sounds like it needs some pretty robust control features.
It does, and for professional use, those management features are critical. This includes OSD or on-screen display insertion, so you can do things like pop-up live campus alerts, emergency messages, or just branded logos right into the feed.
So you can overlay information on the fly.
On the fly. And you can also modify all the program info, the channel mapping, and it's all managed remotely through a simple web browser. It's a really easy-to-use controller for a highly complex system.
So if we connect this back to the bigger picture, this device it's really a profound illustration of how technological legacies persist, not because of stubbornness, but because of financial necessity.
That's the perfect way to put it. It allows all the massive efficiency gains of modern digital video to flow seamlessly into these copper-based analog systems that were standardized decades ago. It's interoperability at its best.
So what does this all mean for you listening? We just talked about a bridge device that links modern IP video to old-school RF coaxial cable. Considering technology keeps pushing towards higher resolutions and faster speeds, what common established piece of infrastructure in your own life do you suspect will need a similar bridge device to stay relevant in the next 5 years? We'll let you ponder that on the way out. Until the next deep dive.